Hi, everybody. Just want to go over a couple things for today's assignment. This is electromagnetic waves. It's fairly straightforward. The reading is built right in. But as you go through this, the first thing I want you to do is up here, this little hyperlink will take you right to a physics in motion video. It's only about 10 minutes long. It'll walk you through most of the information you're going to need. It does a really good job of describing the different types of electromagnetic waves, from radio waves to microwaves to visible lights, X-rays, and so forth. So it'll help a little bit. The other thing it'll review is it'll review the idea of frequency, wavelength, and speed. Those are all going to come into play. Now, one of the things it's also going to do play here is what's called the electromagnetic spectrum. Now, electromagnetic spectrum is important because these types of waves don't require a medium. So far, all the waves we've looked at require a medium, whether it be air, water, solids. Now we're actually dealing with something that can travel through space. So electromagnetic waves, like light and gamma rays and radio waves and so forth, can travel through space. So that's going to make a huge difference. Now, when you're reading this chart, a couple things become very important. Notice that as you work your way to the left, the wavelength gets longer, okay? Which means our radio, microwaves, infrared, they're all going to be fairly long waves. As you work to the right, you have ultraviolet, X-rays, and gamma rays. Those wavelengths are going to get much shorter, but they also have a lot more energy. So energy and frequency is going to increase as you work your way to the right. Okay? So fairly straightforward. The next part just gets into a little more detail on frequency, wavelength, and speed. And this is the equation that we've used before. The only thing we've done is we've substituted C, which is going to be the speed of light, for V. And again, nothing really terribly different than what we've been doing in calculating speed. Now, I did scribble a little bit down here. It shouldn't be a V, it should be an F down there in that column. Speed of light is 3 times 10 to the 8th meters per second. The questions, the first batch of questions here, are all straight from the video. So where it says video questions, you have to watch the physics in motion video to be able to answer those questions. So again, if you come back, question 4, these are all part of the video questions. Diagramming, they actually will diagram a wave so you understand what it looks like. Write the speed of wave equation for light, that's on the previous page. And then what is the speed of light? Again, all straight from the video. And then it says list properties of different types of electromagnetic waves. For example, radio waves, we definitely transmit information when we listen to the radio. X-rays we can use to look through tissue and actually see broken bones and things like that. So you're just looking for examples of what the different types of light do. Now, so what color, 13 and 14 again are questions that go along with that. The next group, there's actually a vocabulary word bank here. There's a diagram, again, it's looking for characteristics of different types of waves. So you use the word bank to fill in the blanks here. Any question answer separate on this page, and then it continues through through question number 11. Question 12 is just matching. Again, goes back to the different types of waves. And then 13 through 20 are questions dealing, those are just true or false based on the statement. And again, the video helps a lot here. And just going through and understanding what each of the different types of waves does will be helpful. Now, the part I want to help you with the most is this page here. This is the short answer part, if you can call it short answer part. The first, if you go back to that diagram on the very first page, there was an electromagnetic spectrum. Now, I've got one in here that's in color too. We can use to kind of work through some of this. Now, it says yellow light has a longer wavelength than green light. Which color has a higher frequency? Okay, so here's my yellow light. Here's my green light. Okay, so remember, if I'm moving to the right, what happens to my wavelength? What wavelength? It gets bigger. If I move to the left, what happens to my wavelength? My wavelength gets smaller. If I move to the right, what happens to my frequency? My frequency actually does what? It actually decreases along with my energy. As I move to the left, my energy is going to start to increase, okay, along with my frequency. So you kind of see that listed here. It's more, so frequency goes up as I move to the left. Wavelength goes up as I move to the right. Okay? Now, to answer our question then, it says yellow light has a longer wavelength than green light. Which color of light is the higher frequency? Well, am I to the left? Is green to the left or to the right of yellow? Okay, it's to the left. So what that would tell me then is my frequency is actually going to be greater. Okay, because as I move in this direction, my frequency is going to increase. So on this one, my answer is going to be green. Okay, sorry, I've slid off the page there a little bit. Let's take a look at the next question. It says green light has a lower frequency than blue light. Which color has a higher or longer wavelength? Well, again, we can go back and take a look at the diagram. Let me slide this up here. Let's see if I can make this work. All right. So green is right here. Blue is right here. It says green has a lower frequency. Okay, that's true because as we go this direction, the frequency is going to be lower. And so green has a lower frequency, blue has a higher frequency, but it's asking which was that has the longer wavelength. Well, keep in mind, as we move to the left, what happens to our frequency? It's going to go up. If we move to the right, our wavelength is going to go up. So this one's asking about wavelength. So because green is to the right of blue, my wavelength is going to be greater. So this is also going to be green. Okay. Now, the next couple of questions, cover them up so we can just do one at a time. It's going to have you do some calculations. Now, the calculations aren't difficult here, but I want you to practice with it a little bit. Now, the first thing you want to probably do is put the triangle in place. Okay, where C is the speed of light, and then you have lambda, which is wavelength, and F, which is frequency. All right, so in this one, we're trying to calculate the wavelength. Right off the bat, we know we're missing the wavelength. Okay, we know the frequency is 750 times 10 to the 12th hertz. Okay, and we also know the speed of light because that's a given. That's 3 times 10 to the 8th meters per second. So, using our triangle like we've done in the past, what we're going to do is we're trying to solve for, in this case, wavelength. So we'll cover up wavelength. So that tells me that wavelength then is equal to C divided by F. So if I plug these numbers in, I get 3 times 10 to the 8th meters per second divided by 750 times 10 to the 12th hertz. Okay, so let me grab a calculator. I'll plug those numbers in. All right, hit the clear button. So 3, I have to use the EE button to get, wrong button, clear. 3 second EE, 8, that's speed of light, divided by 750 second EE 12 gives me the answer of 4. So in this case, I get 4 times 10 to the minus 7 meters. That's going to be my wavelength. Okay? Hopefully that's straightforward enough. Let's do a couple more just to help. The next one. Let's calculate the frequency. So this time we're looking for frequency of yellow light with a wavelength. So we know the wavelength is going to be 580 times 10 to the minus 9 meters. And speed of light again is going to be 3 times 10 to the 8th meters per second. Okay, so if we're going to go ahead and solve for, in this case, frequency, cover frequency up. So C divided by the wavelength is going to give me my frequency. So frequency is equal to C divided by lambda. So if I plug those numbers in, 3 times 10 to the 8th meters per second divided by the wavelength, in this case, it's going to be 580 times 10 to the minus 9 meters. Let's plug this one in. So I get 3 times 10 to the 8th divided by 0.580 EE minus 9, and I get 5.17 times 10 to the 14th. And this is actually going to be frequency, so my units are going to be in hertz. Okay, one more, just so you understand. And that way I've done a few of them for you. It says calculate the wavelength of red light with a frequency of 460 times 10 to 12 hertz. So right off the bat, we know that we're looking for wavelength. Frequency in this case is going to be 460 times 10 to the 12 hertz. Speed of light doesn't change, it's still a constant. So that's going to be 3 times 10 to the 8 meters per second. This time we're looking for wavelength. So again, I can put my finger over, and wavelength is equal to C divided by F. Plug in our numbers, 3 times 10 to the 8 meters per second divided by 460 times 10 to the 12 hertz. Clear. Plug these numbers in. 3 EE8 divided by 460 EE12, and I end up getting 6.52 times 10 to the minus 7, and that's going to be meters. All right, so I kind of walked you through a few. Hopefully, if you have any problems or questions, shoot me an email. I've got the discussion board open too, so if you want to ask a question on the discussion board, we can go from there. I hope everything's going well. Have a great day, and hope the list helps. Bye. Take care.